Now here's one of the cool part about this particular part of the molecule. If H2O is your conjugate acid, what's the nature of the base? What base does H2O come from? To get back to the base, you make the acids do what the acids do. What do acids like to do? Gain hydrogen or lose hydrogen? Lose hydrogen. If I have the H2O lose a hydrogen, I become my base, which will be OH. If I know the CO minus is my conjugate base, and I want to know what acid the CO minus come from, all I have to do what the base like to do. What the base like to do? Gain hydrogen, lose hydrogen, gain the hydrogen. If I gain the hydrogen CO minus, I become HCl. Wasn't it fun? But you're probably saying, that's a little easy. Give me something that's challenging. Jasmine was saying, give me something real tough. I'm like, Jasmine, I ain't gonna think about something real tough like that. This is Jasmine ass. Jasmine ass. Let's get another molecule. And you want to draw the product or products of the following acid-base reaction. Now, before you're going to do the product of the reaction, first you're going to just relax. Now, the acid-base reaction, since we already know it's an acid-base reaction, we know one of our molecules must be the acid, one of the molecules must be a base. Is there anything to help us know that the molecule will be an acid or a base?
That it will be?
No, I mean, fall between the two. How do you know which molecule, which one's the acid, which one's the base?
I would say it's the H2 so far because that's extra.
So notice that there's like charge there too, right? Going back to G-Chem, which atoms had charges? Acids or bases? Bases. When we HCl didn't have a charge, right? But we know if base is going to hit base, for example, OH minus. Minus generally goes with bases. So notice here, if I want to show, like I got a minus go with bases. But also, what also have present? What's this right here? Hydrogen sulfate. Give another name for it. From G-Chem. Sulfuric acid. The sulfuric acid, if it was acid in G-Chem, it's still going to be an acid in organic chem. It's not going to just like, yeah, it was sulfuric acid in G-Chem, but it will rule the change when I got to organic. No, it was HCl that was an acid in G-Chem, it's still going to be an acid in organic chemistry. Sulfuric acid was an acid in G-Chem, it's still going to be an acid in organic chemistry. Nitric acid, which was an acid in G-Chem, is still an acid in organic chemistry. It does change a little bit on that one now. So again, I said we have two molecules. We can either look for common acids, or if there's common acids not present, look for a charge. Minus charge typically goes with bases. Acids typically will be an H2SO4, they're a charge shown. Anybody see the charge? Now you see the charge here, and how we know the charge there? Because it's listed. So when you get this stuff here, like, don't start going like, oh, I don't know how to figure the chart there or not. I'm like, if you gotta go like, so like about to take a dookie and stuff, you gotta do the right thing. And the hard dookie coming out like that. But no, the dare and stuff here, it should be actually shown. I'm not trying to trick you about being shown there. Notice the minus chart is actually listed as far as shown. Notice right here, there's nothing shown there. You gotta go into like, some there or not, like, you know there's nothing seen there. So then first thing you're going to identify the acid and bases. This is your acid. This is your base. All we're going to do is make it do what it do. Acid like to do what?
H.
Donate an H. If I lose an H, I become what? Oh, what atoms do I come from? Don't have to name it first. What do I become first? H, SO4. Now once you get the molecule, you can then call this will be your conjugate base. Because remember, you're not going to be base, you're not going to be a base, you're not going to be an acid on both sides. If I start with an acid, I'm not going to end with an acid. So if I start with an acid side, my product will be the base, the conjugate base. Now I have my base. What do bases like to do? Gain a hydrogen to go from NH2 minus to NH3. This is your conjugate acid. Wasn't it fun? And you're probably saying, why he's good? Like, that's not a whole challenging one as far as doing that one. Let me go get an even more challenging one for you. Give me a product of the following acid-base reaction. First thing, relax. In our acid-base reaction, the first thing you need to do is to identify the acid and or the base. In our second reaction, can we identify either the acid or the base in the second molecule?
Yeah.
Can we identify anything in this molecule?
Yeah.
What can we identify?
The base.
And what lesson do we identify the base? We got a minus charge. Remember in GChem, OH minus was a negative with a base. Minus charge go with bases. So we got C3 minus going to be our base. So the first molecule must be my acid. What's the product's reaction? What does acid like to do? Lose a hydrogen. So instead of having a carbon with 4 hydrogen attached, we're going to have a carbon with 3. Didn't matter which carbon atom lost a hydrogen? Why not? You can all got the same. All carbon got the exact same attachment. So if I move a hydrogen atom from, there's nothing special between this carbon atom versus that carbon. They both are the exact same. This here will be your conjugate base. Now we have CH3 minus, which is a base. Base like to do what? Gain a hydrogen to become CH4. Does CH4 have a charge? No. Now, for the little charge one, remember for our GChem, you got to do a charge balance. What's my overall charge of my reactants? The overall charge of reactants. +1, -1, 0. Overall charge is -1. To be a balanced one, my overall charge, my product also must be -1. You can't start with a 0 and then end with a -1 or something like that one. Whatever the overall charge is for charge balance, if my overall charge of reaction is -1, the overall charge of my product also must be -1. I got another jab. She was asking, but what if I have like a couple different acids and bases? How do I know which one is stronger? Jab, that's a pretty good question. How was you expecting that particular question to come out, though? Because you're asking H2O versus NH3. Which molecule is the stronger acid? What's the stronger acid between H2O and NH3? H2O. Say H3O? I mean, H2O so with NH3. Acid actually turned to be H2O. Now, this video also relates back to those handy-dandy periodic tables. Turns out strength of acid increases from left to right. So trends determine the strength of acids. There are going to be 5 rules. Number 1, strength of acids. Increase from left to right. And cross appears. And what I do for the atom from left to right, I'm not looking at the hydrogen atom, I'm looking at the hydrogen atom directly attached to it. I'm comparing O versus N. If you look right here, like it's like O, because both atoms have hydrogen atoms in common. The hydrogen atom will be a mu point for each one of those individual molecules. So basically, I look at N versus O. Going from left to right, the strength of the acid increases going to the right. Going to the right. So we got N first, then followed by O. Well, what if I have HCl versus HBr? Which one is stronger between those two? It's a 50-50.
So they right on the same.
So which one are you going with?
He said cross my up and down.
That's what I'm saying. See, just be here, HCl and HBr, you can't do that rule going across. It's not going to solve the problem for HCl and HBr because both of them say get up and down to each other.
So HCl. HCl.
Not HCl, HBr. That goes to rule number 2. Strength of acids increases from top to bottom. Down the column. So as far as the strength of the acid series, HF, HCl, HBr, HI. Which one is the weakest acid? HF. Hydrochloric acid act the second weakest. Anybody happen to know why we don't actually use HF because it's the weakest acid in the lab? Happen to know why we use HF?
I mean, just thinking about it deductively, I think that you might need, if you add a treatment to it, you can't really see the changes, or you can't really measure changes in, what happens to it if you were to do an experiment. Yes.
There was like a process for like student was dealing with acid, probably say, hey, we want the undergrad student to deal with like weak acid. They want really strong acid dealing with them. If you're dealing with the state about weak acids, why not use HF, do you?
Yeah, that's the same like, if you're trying to introduce some variable to HF, you're less to see a change because it is so weak. Or you're less to see.
Yeah, it's going to be like a weak acid. It's like it's not a really strong. It's considered to be a weak acid one. So you have a slightly different nature compared to strong acid, strong base type one. That is true, but that's really the problem. Problem with HF is really more of a health issue as compared to a reaction issue. One of the problems dealing with HF is that HF eats up glassware, so you can't store it in regular bottles. But that's not really the reason. We can always make plastic glassware for you. Another problem dealing with HF is that HF has a little bad habit of leaching out the calcium from bones. So eventually you go ahead and do like for so many years of stuff doing that when you basically cause your bones to age to somebody that may be in the 60s. You may go on somewhere and stuff, you also you like hit your hand and stuff dead and also break your bone stuff in your hand. Most individuals stuff you don't have to look too nice to have like students being all mutilated and stuff in labs. Also because like the fact about like leaching the calcium for the bones and stuff in the body, it's a bad thing, and so that's the reason why we actually even use HF. And also again, you got to come with a special different type of glassware. But again, because it's plastic, so plastic use so often now, so the fact about plastic is not as big of a deal compared to the fact about it still just leaches the calcium for your bone, which leads to a whole bunch of lawsuits in the future. But again, so I want to get too much bogged down. Yes.
So, a quick question. You kind of have a problem with the H2O versus the NH3?
Mm-hmm.
Are you referring to like the pH level when you said like the stronger acid?
Yeah, because for the stronger acid, the lower the pH would be also. But in biology, what's NH3 referred to in biology? Is a what? A natural what? Natural base. So if this is a natural base.
That's what I'm saying. Like, so it's going to be considered acid.
Oh, you can make it to an acid if you have a strong enough acid present to it. We have sulfuric acid. Sulfuric acid will protonate NH3 to form NH4 plus. Now again, it's actually if you got a strong enough, you know you get a protonate because it's a base anyway. But if you got like a strong enough base, for example, CH3 minus will pick a hydrogen atom off of NH3. Because it's way much stronger than OH minus. Now if you get strong enough acid, but also water's not considered to be an acid or a base. But you can make it to one of the two by putting if I put a strong acid like sulfuric acid to mix sulfuric acid with water now becomes the base to sulfuric acid. But if I put OH minus in sulfuric acid, if I put CH3 minus plus H2O, CH3 minus is such a strong base, it makes the H2O an acid. And that depends, like now generally water is not considered to be acid or base, but you can make it one way or the other depending on what you actually add to it. So I want to answer that particular question. What if I had C2H6 versus C2H4? Now the first two rules, neither one can help answer that question. Because carbon is going to be the same carbon atom going left to right. same carbon atom go on top. But is there a difference between the acidity of the hydrogen attached to those two different type carbon atoms?
The one with the less hydrogen,
Is it more acidic or less acidic?
more, because they like to lose, or
Well, it's actually more acidic, but it's not because of that particular reason now. This being more acidic. A triple bond will be more acidic than a double bond.
You said what?
A carbon-carbon triple bond will be more acidic than a carbon-carbon double bond, provided they have a hydrogen atom attached to it. And what rule do you think we use in order to determine the difference between the two carbon atoms? We've done it already. Start with an H. Hybridization. That goes to rule number 3. The strength of an acid.
And then we'll do that as a full class. And then on June 16th, which is actually
Increases
that's when you're going to go back
with increase in S character.
audit for your main business practice, recycling, and seeing if you're fired and your activities providing events and behavior made any difference.
And you're like, what in the world are you talking about? What's increase in S character? He's trying to give me the old hokey doke or something. Now for the carbon atoms, we got a carbon-carbon single bond. That will be sp3. A carbon-carbon double bond will be sp2. And a carbon-carbon triple bond will be sp. And we're going to see if it makes sense about this increase in S character. If I was looking at sp3, how many total orbitals am I looking at? How many s orbitals do we have? One. How many p orbitals? Total, I have how many orbitals? Of those 4 orbitals, how many is s? 1 out of 4. Or 25% s. Right? If I look at sp2, how many total orbitals do we have? 3. 1s, 2p, total 3. Of those 3 orbitals, what percentage is s? 1/3, which is 33%. In sp, I have a total of how many orbitals? Of those 2 orbitals, what percentage is s? 1/2, 50%. Notice you go from the sp3 to sp2 to sp, you go from 25 to 33 to 50%. So as you increase with the S character, you also increase with acidic. Which, yes.
I'm kind of confused because I'm not seeing how that correlates with that. I don't see it.
So when we compare these two, now basically, honestly, both carbon atoms got a hydrogen atom in the molecule. What's the difference between those 2 carbon atoms? It's a hybridization of them. One is single bonded, one's double bonded. If I were to figure out what hybridization is such a carbon atom, I will identify the carbon atom, how many atoms are attached to the carbon atom? To this carbon atom, how many atoms are attached to it? 4. When I say 3, I count 4. That's 4, right?
yeah.
Plus, how many lone pairs are around this carbon atom? 0, because the carbon wants to have 4, and it has 4. So I don't have to add any more to it, so it's 0. I will get 4. I will use S, P, and D to make a 4. The hybridization will be S, P, 3. Now I'll look at my next carbon atom. by my citric carbon atom, which is this carbon atom here, how many atoms are directly attached to the carbon atom? 3. And not to my bonds, double bond ones, like 1, 2, 3 atoms. So it's 3. Plus, how many lone pairs around this carbon? 0. I'll end it with 3. Hybridization will be sp2. So I'm comparing sp3 versus sp2. If I look as far as S characters, I got 25% versus 33%. The one with the largest percentage of S characters would be the stronger acid.
And this is when we're comparing.
But no, therefore, like we had to use rule number 3 because rule number 1 won't determine between those two.
Right.
Because I'm just looking at the atom, carbon versus hydrogen. The only atom is the hydrogen atom become for all the atoms, for all the acids. So I'm looking at carbon versus carbon. Rule 1 is not distinct between the two carbon atoms. Rule 2 is not distinct between the two carbon atoms. You have to have another rule to distinct between the carbon atoms of the molecule. But you're probably wondering, is that it as far as the rules? You know it's not. So what if I have COH versus C double bond O OH? In this molecule, I have 2 atoms that have hydrogen atoms directly attached to it, carbon and oxygen. Which hydrogen is more acidic, CH or OH? Remember your rules, C versus O, which one is more acidic? O, OH, and O, a hydrogen at the top of oxygen. So we have OH versus OH. Which one of those two is more acidic? The first molecule or the second one? Then the next question is why? Because if you do OH, if I'm doing the OH right, I got OH versus OH. If rule number 1 tell me which one is more acidic? No. If rule number 2 tell me which one is more acidic? No. If rule number 3 tell me which one is more acidic? Look at the hybridization of the oxygen atom with the O's. Which one is more? Both of them will be sp3 hybridized. This carbon, this oxygen atom also will be sp3 hybridized. So rule number 3 does not distinguish between why these 2 OHs are more acidic than the other one. We have to go to something we mentioned about earlier in class. Starts with an R. Resonance. If I lose a hydrogen, if this oxygen atom was to lose a hydrogen, I will put a what charge on my oxygen? A -1 charge. If I put a -1 charge on this oxygen atom, can I move that minus charge to be shared among more than one oxygen atom? Yes. Alternating single double bond, the little charge. Instead of one oxygen atom being a -1, I make the second molecule a -1/2. The more, the more you lower the charge, the more stable you make the molecule. The more stable to make the molecule, it means the molecule more readily they're able to fall apart to form an H+. But again, when I try to use like a rule, it's a little more easy to try to follow without trying to do the whole rest of the stuff. The more oxygen atom present, the stronger the acid. Not quite the Fisher rule and stuff, but it's probably easier to follow than the whole rest of this type one. Rule 4. The more oxygen atoms present, the stronger the acid. for example, if you were wanting to figure out which acid is stronger between sulfuric acid and hydrochloric acid, H2SO4 versus NO3. Without drawing a molecule, you're probably thinking like S versus N. It's actually not S versus N. If you were to draw them out, if you're drawing them out, rule number, it's not a S versus N as far as the rule one, because the H is not attached to the oxygen, not attached to sulfur, nor is the H attached to the nitrogen. The H is actually attached, in both cases, attached to an oxygen atom. So if I use the first rule, I got OH. I can't distinguish between this as far as rule one. I can't distinguish between rule two. Can't distinguish between the two because of rule three. Here I have 1, 2, 3 oxygens versus 1, 2, 3, 4 oxygens. Which one is stronger acid? Sulfuric acid. In fact, sulfuric acid is such a strong acid, it acts as an acid to nitric acid. It actually protonates nitric acid in a reaction.
Where's the one before?
We have gone through 4 rules and we're still not done.
Dr. Pearson, for the previous one, which one was stronger, the H3C or H?
I mean, the carboxylic acid. This is the alcohol. This is a carboxylic acid. I'm not speaking there was carboxylic acid. We didn't talk about the functional groups yet. But you're probably thinking we're already done, and we're at least there's still one more little rule left. Versus A. B. Which one's the stronger acid between molecule A and molecule B?
B.
Now remember, all the rules we did so far could not distinguish between molecule A and molecule B. If you look at molecule A and molecule B, there's something kind of can you notice a little difference between molecule A and molecule B? What you notice different? As far as atoms.
The hydrogen and the
Fluorine. Hydrogen and fluorine. What do you know about fluorine? Most electronegative atom on the periodic table. And with electronegative atoms, what they can do for the electrons. They don't want to give electrons off, they want to pull electrons back to them. What do you want to do for electrons? They want to pull electron density toward itself. So what it does, when it starts putting electron density away from this carbon atom, the carbon atom says, I need to get some electron density from someplace too. So this carbon atom, that radon the fluorine start putting electron density away from the carbon. It's going to make that carbon atom a partial positive charge. The carbon will say, I'm going to pull electron density away from this C-double-O carbon. The C-double-O carbon says, I'm going to start pulling electron density from that oxygen atom. And we think the oxygen atom is going to do to the hydrogen atom. It's going to start pulling electron density from the hydrogen atom. When it starts pulling electron density from the hydrogen atom, it's going to make the hydrogen atom or partial what charge? Partial positive. Partial positive also makes it more acidic. The more partial positive charge you do, you make it more H plus like, making it more acidic. Number 5, strength of acids. Increases with inductive effect. The inductive effect is the electron withdrawing effect. Now, I would say the inductive effect only works if it's pretty close to the acidic atom. If you put it far away, you put it far enough away from the acidic atom, the molecule don't even know there's a atom with fluorine atom attached to it, a carbon atom with fluorine atom attached to it in the first place. Again, it got to be pretty close to where the acidic atom would be. In the case, it's the OH group. And I got Marvell was saying, like, he was asking me, how are you going to ask this question here on exam numero uno? And I'm like, shit, I was trying to figure, not you mention it to you. But let's suppose if I give you like 5 molecules, I want you to arrange it in increasing or decreasing order according to acidity. Arrange following molecules you want to increase or decrease it?
Increasing. That's easy.
And increasing order of acidity. So basically, I'll give you 5 molecules. You want to arrange them in order of increasing order of acidity. The first thing we try to do is before we put anything together, we need to define what's preferred to increase. Increase it goes from what to what? The strongest to weakest, or the weakest to the strongest?
The weakest to the strongest.
So basically, so we want to get it together. We talk about increasing one. Because if you don't end up putting it in the correct order, you can do all that work and stuff you want to and still get the wrong answer. The first thing we do is relax before we start doing anything. We need to make sure we understand what the question is asking us. It wants to go in increasing order. We need to go from the weakest to the strongest. Weakest to strongest. So now we know what order we want to go into before we start doing anything for the molecule. Now we'll look at the molecule and look at the atoms that the hydrogen is directly attached to. We're going to see we're attached to a carbon, chlorine, sulfur, phosphorus, carbon. We're going to take those. Make sure I'm good. So on the periodic table, we're going to have carbon, phosphorus, sulfur, chlorine. That's basically how this molecule look on the periodic table. On the periodic table, the strongest acid is going to be what?
The left. I mean, the right.
On the right. So the strongest one going to be
Chlorine.
HCl. This is going to be the strongest. The weakest is going to be what?
Carbon.
The carbons. Now we got two carbons. We know that these two are going to be the weakest. We don't know which one or two. We know this will be the weakest. Now, for us to know, we know that the strongest is going to be Cl followed by
So,
sulfur followed by phosphorus. So we got 3 to 5 molecules already set. So we got B is going to be first, followed by, for the weakest.
the weakest is carbon.
We got chlorine at the bottom. This is going to be, we got B. Going from right to left, got B. Then we have C.
D.
Then we have D. We have not finished the first two. Now we got, for the first two, we got A versus E. Which one is stronger as between A versus E? A. So that makes E the weakest. So it'll be EADCB. Now you try to, I like to put like 5 answer stuff in there because it's more fun to have 5. It's like 4 is no fun. Everybody probably guess 4. 5 requires you to go ahead and rank them. And even more fun would be, instead of having you tell them to put them in order, have you list the second strongest or the second weakest. More fun. And again, the stronger the weakest, stronger the weakest, the end part of it, you can about get the end part of the molecule. But we got to go to the second strongest, second weakest, you got to start ranking them. It makes it more fun. Everybody got the little 5 rules and stuff on there? Yes. A with a carbon-carbon triple bond will be stronger than a carbon-carbon single bond because of the increase in S character. You got an SP versus SP3. For exam numero uno, I would ask you to give me 3 of the 5 trends in order to determine the strength of an acid.
You say
I'll ask you to list 3 of the 5 trends in order to determine the strength of an acid. Who get to pick which 3 trends you want to use? You get to pick. Most of the time I'm going to do is try to focus on maybe the first 3 rules as far as that goes. Because those we had to try to use every single rule, so I'm not trying to go ahead and I just want to see if you at least get a feel about when like far the strength between acid and bases. I'm not trying to get you to exhaustively so you can remember every little single thing. I do want to see, can you at least get a feel about, if I saw 2 different acids and bases, which one is strong, which one is weaker one? And why is that important in the first place? Because not all acid-base reactions lead to anything. Then we did the reaction as far as like a HCl plus NaOH, and you get HCl plus H2O. And I can put a little O minus type thing stuff on y'all to make it easier. Now from GChem, when we notice acid-base reaction will occur. But why does the reaction occur? In all reaction like nature always want to go downhill. As far as like naturally, You can get weak by just sitting around doing nothing. But it takes a whole bunch of effort to get strong though. Nature always want to go from strong to weak. You want to go from strong acid to weak acid. Going from strong to weak is a spontaneous process because it goes downhill. Now, in order to figure out now far as a little strong acid, we're going to compare acid versus acids. We're going to compare our acid, which is HCl, versus our conjugate acid, which is H2O. Between the two, which one is the stronger acid? Because you got C versus O. C is going to be stronger than O. HCl is a stronger acid going to water. That's the reason why the reaction is favored, because it goes from strong to weak. Will reaction B occur? To see reaction B occurs, we have to compare acids versus acids. First thing we do in this molecule here, we have the reactant side of the molecule, that active side of the reaction. Of those two molecules, which one is our acid, which one is our base?
That's the base.
Which one's the base? OH minus. If this is the base, other molecule must be our acid. When an acid loses a hydrogen, it becomes a conjugate base. And a base gains a hydrogen, becomes a conjugate acid. So to see the reaction occurs, we're going to end up comparing acid versus acids. We're going to look at CH versus OH. Which one is stronger acid? CH versus OH. OH. This will be strong. This will be strong. It will be weak. Where my equilibrium reaction line go? From reactant to products or products to reactants? Products to reactants. Which means you to put these two things together, they'll look at you and like, what you want me to do? I can't move a hydrogen atom off that molecule. I am too weak of a base to move a hydrogen atom off to move an H off a carbon single bond molecule. So just because you may put them together and call it an acid-base reaction does not necessarily mean a reaction will actually occur. Just like some in GChem, when you put like react stuff together, and if you do like a little spectator ions and stuff like that, when the ionic was a net ionic equation, if everything matches stuff out and stuff here, no reaction occurs. You also can have stuff with acid-base reaction, but no reaction actually occurs.